Welcome back. In the previous subunit we covered the fundamentals of hypothesis testing. In this unit we are going to learn about some common tests which are performed on the normal data. Thus, we must note that when we are going to perform these tests, we need to make sure that our data is approximately normal. To understand how to check normality of the data, you may again revise the lessons in Unit 2 where we discussed data characteristics and normality. This particular lesson will talk about the steps in hypothesis testing with the help of an example. If we see this flow chart, we can understand when to perform what type of test when data is normal. As we can see here, for normal data type, when we want to compare two means, we can make use of t-test. If population variance is known, then we can perform z-test. In this lesson, we'll discuss an example of hypothesis testing with the help of z-test, which is used when population variance is known. In next lesson we'll learn more about the different ways a t-test is used. We must again make a note here that hypothesis testing is done to make inferences about a population parameter with the help of sample statistic. We are not making inference about samples. As we have learnt in previous lesson, these are the steps to perform in hypothesis testing. Let us take an example and learn how these typical steps are performed. So, our problem question is that the average turnaround time is significantly greater than the target turnaround time of 8 days. We can formulate our alternate hypothesis first, based on this concern. Alternate hypothesis is, mean turnaround time is greater than 8 days, and accordingly our null hypothesis would be that mean TAT is 8 days or less. This is a one-tailed test. Hypothetically and historically we know that the population standard deviation is 2 days. Total data points we have taken are 660, and let's assume that the data is normal. We also know that n is equal to 660. When we are manually testing a hypothesis, we need to calculate a value called test statistic. A test statistic is compared with a critical value, and if it is greater than critical value, we reject the null hypothesis. Here we'll calculate z statistic with the help of this equation. Remember, we have to do a one-tailed test here. Z statistic comes out to be 38.49. Next, we find out critical value. Critical statistic in this case is the value of z at the chosen level of alpha, that is 0.05. To do this manually, we refer a table, the probability table or the z table. Since we have chosen level of significance as 0.05, we'll find the probability in the cells given in this table, and then match it back to z value. The 0.05 is matched to the row value of 1.6 and column value of 0.04, thus the critical z value is 1.64. This means that beyond the standard z value of 1.64, the area under curve is 0.05. Let us understand the significance of this with the help of this standard normal probability curve. In this graph, mean value is 0, let's plot it on x-axis. Under this curve, the total area is 1, means the total probability is 1. Now we want to find the point beyond which the area is the rejection region, which we have already set as 0.05, the alpha. So in the probability table that we just discussed we find the value of 0.05 in and corresponding z value. It comes out to be 1.64. We plot this z critical value as here. So we know that beyond this point, the area is 0.05, the chosen level of significance, thus the rejection region for this test. As our test statistic or the calculated z value is equal to 38.49, which is also somewhere on the x-axis of this curve, we want to find if that value is in the rejection region or not. If we compare the calculated z statistic and critical z statistic, calculated z statistic is very higher than the critical z statistic, and plotting it on the scale will show that it is lying in the rejection region. Here is also the chance to understand what is the p-value. P-value is the area under the curve beyond the calculated z statistic, which in this case happens to be 38.49. Let us assume the area beyond z calculated, the p-value, comes out to be 0.0001. This way we can also prove that the z statistic is lying in the rejection region, as this is lesser than the alpha. Now we know that z calculated is greater than z critical. Alternatively, p is less than alpha. We reject the null hypothesis. Thus we can conclude that at the level of significance of 0.05, the mean turnaround time is significantly greater than 8 days. In the next lesson, we will learn about the different ways in which a student's t-test is used, along with examples. Here we come to an end to this lesson. Should you need any support, feel free to contact us. Thanks for watching this video, and see you in the next lesson.